Assalamu alaikum.
Walaikum salam.
I think you're really tired, right? You've been out all day.
I'm pretty tired. Yeah. My legs are demolished, so I
Okay.
wasn't supposed to work the weekend,
Okay.
but I worked on both days because I was asked,
Hmm.
which is amazing. How are you doing today?
Alhamdulillah, I'm doing fine. Okay. So let us start permutation and combinations, right? We just had a little brief discussion on permutations and combinations. Now, these two things might seem like very closely connected. So first of all, let me like differentiate between these two first of all. So when will you use permutation and when will you use combination? Okay, first of all, for permutations. Okay, so like when you like the words I am like translating, but you will understand what I'm trying to say. Okay, when you have to order or arrange things, then constructing numbers. I don't know how many of these maths are covered in your book. Okay, constructing
Mm.
numbers. Okay, people, voting personnels. Whenever we will see the maths, these things will get easier. Okay, distributing prices. Arranging in a cyclical order, etc. Now for combinations, choose something. Choose, or you could say select as well. Select. Okay. Creating teams. Or committees. Creating triangles or polygons, you could say polygons, right? Like for geometric things actually. Okay, divide in groups, etc. These are the problems regarding permutations and combinations. Like whenever you are seeing these sort of things mentioned in a question, you will use permutations, and whenever you are asked to do something like this, you will do combinations. Okay, the previous day I showed you a particular example regarding how you can travel from one place to another. Okay. So that was something like say, Sydney here and Perth here and then Melbourne here. Okay, right. So there was like say number one method, number two method, number three method. Okay, and here again there were two methods, like you could consider number four method and number five method. Okay, and what did we consider? That in some way we are going to Perth first, and then with the help of these two ways we are going to Melbourne. And at the end of all of it, what we found was there are total number of six like permutations or six ways we can reach Melbourne, right? Remember that?
Yeah.
Okay. Now see, here comes the main principle of permutation. Principle of permutation. So see, here there were three total ways you could reach from Sydney to Perth, and here there were total two ways you could reach from Perth to Sydney. Okay. So now reaching Melbourne is dependent on how you reach Perth, right? That means these two events are dependent on each other. Is that correct? Okay.
Yes.
Okay. So now the first principle comes from there that whenever you see a dependent event, you will multiply. For you might have read that in like probability as well. I don't know if you have read that. So for dependent events, multiplication will be used. Multiplication will be used. Okay. And where do we apply the multiplication? See, for the like former like thing or former process and the latter process, their results or these two events will be multiplied. Okay. And in case of independent events, you will use addition. For independent events, addition will be used. Addition will be used. Let me know when you are done with all this.
Done.
Now, what is a factorial and how do we get like 0 factorial equals to 1? I've already explained that in the previous class. Okay. And floor values won't be needed by you, but whenever you are asked to say, for instance, you might be asked something like this, like 8 factorial, change it into or like represent it with only prime numbers powers. Okay, represented with prime numbers powers. Let me just show it to you. Maybe it's not part of your syllabus. Represent it with prime numbers power. So what do you have to do? You will obviously first of all like write down what is 8 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, now 8 is not a prime number, so you will try to make 8 or turn 8 into 2 into 2 into 2. 7 is a like prime number, no problems there. Then change 6 into 2 times 3. 5 is a prime number, no problem. 4, change 4 into 2 times 2. And then at the very end, write it something like this, that 2 to the power 7 times 3 squared times 5 to the power 1 times 7 to the power 1. So this is a very easy thing, right? There is no difficult things here, right? Okay.
Yeah.
There are a few advanced things which our teacher also mentioned, but I'm not going there. Okay. They won't be needed. All right. Now, what we have to consider is whenever we are like talking about permutations, there has to be a particular thing involved in every math, which is how do we order or arrange all of these things. Okay. Say, for instance, we have n types of things. Okay. N types of things. N types of things. Okay. And we will arrange or order them. Okay, we will arrange or order them taking all of this together. Okay, we will arrange a, let's say this is something we have to set T1, okay, type 1, say for instance. Okay. We will arrange or order them. How can we arrange or order them, right? So let's see. So let me show you an example first. So we have n equals to 3, and the three types of things are A type, B type, and C type. All right. You could consider any object like A is a ball, and then B is a ball pen, and C is a something other thing. Okay. So now let's see how can we arrange or order them practically. Okay. Let us first consider that I will start with A first. Okay. I will start with A first. So that means this is A at the first. Then I can keep B at the second and C at the third. But another thing can occur that A at the first, C at the bottom, I mean in between, and B at the last. Is it understandable up until now?
Yes.
Let us think that, okay, so all the permutations with starting with A is done. So let us start with B now. Okay. So B at the very beginning, then say A at the A in between, and then lastly C. And in the second case, B in first and then C and then A. All right. All right. Now, is there any other permutation, arrangement, or order possible with starting with B?
Yeah. No.
No, right? So
No.
now, again, starting with C, then we will put A and then we will put B. Okay. And starting with C, we will put B first and then we will put. So that is the total number of arrangement that is possible. Okay, without any repetition. In case of repeating, the things will get a little changed. I will come to that. Okay. So this is the I mean arrangement we can create all the number of arrangements taking each and everything or participating each and everything uh, like A, B, and C all together. Say if I would have said that take only two things at a time, okay, then you might have gotten like more arrangements or maybe less arrangements. Okay, and if I would have said that you can repeat as much as you want, then there would be an arrangement like A, A. There would be another element like A, and B. Okay, so like this, like this. Okay, so we will talk about that later. First of all, let us clarify this. Okay, so now whenever we are not repeating anything and we are considering all the things which were mentioned previously, like three of the things, then we are getting a total of 6 types of arrangements, right?
Yes.
1, 2, 3, 4, 5, 6. Now, there is one interesting thing, that is 6 equals to 3 factorial. Okay. And if you would examine or exercise with like various types of things, say for instance, say you will take two things, okay? Two things. So the number one is say X and number two is a Y. Okay, there is only two sort of arrangements possible. There's X at the first, Y at the second, and Y at the first, and X at the second. So total number is 2, which is equals to 2 factorial. So if there are n types of things, and we are considering that we will like take all of them into account and arrange or order them, that means we will get a total of n factorial numbers of arrangement. Okay. All right. So we can arrange or order them into n factorial ways. In factorial ways. Tell me, did you get up until now?
Yes.
All right. So can I erase these things?
Yes.
Now let us say there is sort of repetition here. Okay. Type 2. N types of things. Types of things. but some get repeated. Some get repeated. So what will happen then? These are like very basic things. I mean, uh, we read it like say for 2 months, I guess, and each and every day our mind were blown. Okay, this is a very difficult topic to be very fair with you. Okay. Now, if there is any repetition, okay, let's see. So first of all, let's say there are two A's, or say for instance, two of the same type of balls, and B means only one type of ball pen. Okay, so let's see how we can arrange them. Okay. All right. Now, say I have kept one A here and the second A here, or maybe I have kept the second A at the first. Is there any way we can differentiate between them? The answer is no, because these two things are exactly identical. Okay, so whichever A you put at first will give us the same amount of arrangements. Okay, so as you
Mm,
can understand, the arrangements will get shrinked. Like if we had A, B, and C, the amount of arrangements we got was 3 factorial equals to 6, right? Is it
mm,
understood? But here
yes.
you will see that we will get lesser arrangements. How? I am showing it to you. All right, so first of all, let us start with B, for instance, this time. Okay, let's start with B. So B, then the other two spots will be like covered by A. In whichever spot you place A, we get only one arrangement, because these two things cannot are not distinguishable, or you cannot differentiate between them. Okay, so very easy to say that. All right, now let us start with A. Let us start with an A. Then we have two spots. Okay, so let us keep the B in between, and then at the last place another A, or another thing could happen, that is start with an A, then keep an A here, and then lastly we keep a B, right? So are there any other possible ways we could arrange them? Think about it and let me.
Can you multiply the B? Like,
How?
can you have multiple B's?
No, no, no. We don't have multiple B's. Okay. The
Then
thing,
no.
in case of like any sort of permutation combination, the total number of objects or total number of people or anything will be given, and then based on that you have to identify the total number of ways you could like arrange them or order them, something like that. Okay. All right, so as you have said, we cannot arrange more of it. Okay, so the total number of arrangements we have got here is 3. 1, 2, 3. Now how is it significant? It is significant because 3 equals to 3 factorial upon 2 factorial. Now this 3 factorial is equals to the types of things, right? Okay. And this 2 is similar things, right? Similar things. So total we had like, sorry, not uh, like type, you could say number of things, not actually types of things. So that's better. It's a better way to say that. Let's say this is similar type of things. So in number of things, not type of things. Number of things, which is 3 number of things, and similar type of things. Which is, we had two A's which were similar. That is why we divided by 2 factorial. In case if we had two B's, then the answer would be 4 factorial divided by 2 factorial times 2 factorial. Now why is that? Because there are total number of 4 things, and there are 2 similar types of A and 2 similar types of B. Listen very carefully, okay? Let me like show the previous things again. See, there are 3 number of things, that is why 3 factorial was there. And in case of like similar types of things, as the arrangements get shrinked, that is why we are dividing by the factorial of similar type of things. Okay, I've showed this to you practically as well. All right. Now, if we are given with like a more similar type of objects, say for instance, there are two A's and two B's. What are the total number of things?
6 divided by 2, which is 3.
No, I'm not saying the total number of ways you could arrange them. I am asking what are the total number of things?
Oh, total number of things is 4.
4, right? Right. So that means if they were not alike, like all of them were different, the arrangement would have been 4 factorial. We have seen that. But as you can see, there are two similar B's, so we divide by 2 factorial, and there are two similar A's, that is why we divide with another 2 factorial. Obviously, you could understand that these are multiplied, okay? All right. So now what would be the arrangement? It is 4 factorial is 24 divided by 2 times 2 equals to 6. Yes. Now let us see if we are correct or not. Okay. So let me erase some of the things. Take note of these, okay? Because as I'm not like teaching you from the book, okay, you never know, something might be needed. Okay, let's see. So first of all, let us start with A. Okay, let us start with A. So if we start with A, then next up, what can we do? We can do is next an A, then a B and B. Okay, they won't be changed. Now let us start with B and B. B and B together, then A and A at the last. There is no change at all if we put the A at the first or A at the last. All right. Now, again, if we keep the A stick at the first and at the last, then at the middle we have two B's. Okay. Then we can start with B and end with B, and in between we can have two A's. And we can start with A and B, and then we will have A and B, or A and B and A and B, and another one is starting with B and then A, and then B and A. Okay. All right. So these are the possible arrangements which we can perform if we like try, forming any sort of arrangements with two alike things. Okay, two or two like four number of things, and in between them there are two alike A's and two alike B's. Okay, and your homework will be, if you can find anything other than these 6 arrangements, you will let me know. Okay, that will be your homework. All right. I know that you won't find it because there are like no other ways, but it will be a
That challenge?
brainstorming. It is not a challenge because there is no possibility to find it. Okay,
I think I hear challenges.
it's not a challenge. You can do some brainstorming which will help you. Okay, all right. It's not a challenge because it is
Okay.
actually like, what can I say? Like 2 plus 2 is equal to 4, right? If I challenge you to prove it 2 plus 2 equals to 5, you cannot do it, right? Otherwise, other than making a mistake. So you cannot call it a challenge. Okay. All right.
Okay.
Because, okay, let me tell you why it is not possible as well. So, see, in case of starting with two A's, the only possible way is keeping the two B's, because they are two alike things. Whenever you change them, it doesn't make any sense. We are starting with two B's, then two A's. So we cannot now start with two A's or two B's together. So what did we do? We started with one A and then one B. Okay. So then at the third place, we are taking a B, and then at the fourth place, we are taking an A. And in another case, we are in the third place, we are taking an A, and the fourth place in a B. And again, we can start with 1B and 1A. Then third place A, fourth place B, third place B, fourth place A. So these are all the ways covered. Okay. There is no other way possible. Okay. Because you can easily understand that if there are two different objects and two different spots, there is only two ways you can calculate it, right? Or like arrange it, not calculate it. All right. Is it like feeling a little difficult?
A bit.
All right. No worries. We will discuss about that. I mean, we will get into depth. Okay. So just to simplify the type 2 of problem. So it will be, say for instance, there are n number of things, n number of things, p of p number, sorry, not, yes, p number of one same type, q number of another same type, r number of another same type, then the total number of arrangement will be, so the arrangement equals to n factorial divided by p factorial times q factorial times r factorial. Okay.
Huh.
Yeah. Done.
Almost.
Let us
Done.
try some maths regarding this. Okay.
Oh no.
No, this is actually totally math. Okay, so we have to keep on doing this maths. All right. So engineering. Okay. We have to arrange engineering. All right. So now with the obviously with the letters in engineering. All right. So now tell me how many numbers of letters are there? A total of how many numbers?
At least 8. So okay, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11.
So total letters equals to 11. All right. Now we have to find which letters are similar and how many numbers of similar letters are there. See, there are 1, 2, and 3 similar E's, right? Right. There are 3 E's, right? And there are 2 I's. There are 2 I's. There are 2 G's as well. There are 2 G's as well, and there are 3 N's. Okay. So these are the total number of like similar or alike things. Now tell me what will be the answer.
So it'll be 11 factorial over 3 factorial, 2 factorial, 2 factorial, 3 factorial.
Yes, exactly, absolutely.
And I have to calculate it, and I had a scientific calculator. Okay.
So the answer would be 277,200. Okay. Total number of arrangement. Okay. Okay.
Yeah.
So these are the like total ways you could arrange them. Okay. So obviously the question setter won't ask that show me all the arrangements because that is not possible. So mainly what whenever I showed you the arrangements in a practical way, that is for understanding. But for doing maths, these are like very little maths, tiny little maths, but will carry a say 4 marks, 5 marks, 10 marks, like that. Okay. Like very little maths. You have to just understand the concept. Okay. All right. All right. Now, say for instance, for Rajshahi, Rajshahi, and Barishal, Barisal. You have to show that the total arrangement of Rajshahi is 4 times the total arrangement of Barishal. Okay. Let me know the answers. Okay. Very easy.
Okay. RAJSHAHI. I have no clue because I got for Raj that one, the first one, I
Yes.
got 10,080.
Yes. And for
I got 2520.
uh,
2,500
now multiply 2,520 by 4.
by 4.
Yes. You will get the Rajshahi one. Okay. That is the question.
Oh, I knew that. I
Yes.
was just questioning you.
All right. So I hope the easy parts and basic parts are done. So now let's dive a little deeper into permutations. So now for all this time, what we were doing was, say for instance, the same amount of letters, uh, like all the letters were being used at a time. Okay. But now we will not do that. We will not do that. What we will do is, say for instance, we have 4 letters, we will use 3 empty spaces. Or we might have 6 letters, we will use 3 empty spaces, and so on, so on. So how can I title it the type 3? Say for instance, more letters, less empty spaces. Like term it like that. Okay. So say for instance, if I say A, B, C, three letters will be used. Letters will be used to fill up two empty spaces. How many ways you can do that? Okay. How many ways?
6.
Yes, yes, 6. Did you?
Oh, no.
Yes, it is 6.
Yes.
Did
Yeah.
you do that in school?
Sort of, yes and no.
All right. So let's see which are the ways we can fill it up. Okay. So first of all, starting with A and then B, A, B. And obviously with it, let's write B, A as well. Now we can start with B and then lastly C. And we could do C and B as well. We could do A, C and then C, A. So the significance to this could be felt like this. Say, for instance, what is for the first box, we can fill it in 3 ways. Okay, we can fill it in 3 ways. However, whenever we are filling this box with one of the letters, we can fill the next box with only 2 letters. I'm saying it again. I can fill the first box in 3 ways. I could put an A or B or C. Okay. But whenever I am filling the first box, say for instance with A, I can only fill the box in 2 ways, which is with B or C. Understand my point?
Yes.
So that means filling of these 2 boxes are dependent events, right? They are
Yes.
dependent events. So that is why 3 and 2 are getting multiplied to get 6. Okay. And there is a very important term which we will learn next. I'm giving you another link, which is NPR. Okay. All right. So I will give you another link because there is very less time left. Okay. Just a second.